Hello, I am Saman Aslam and I am presenting you our project named as IoT based non-invasive glucometer using machine learning, supervised by our respected Dr. Nadia Nawaz. Our project is based on the principle of machine learning in which our device has improved automatically through experience and by the use of data. Machine learning is a branch of artificial intelligence based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. As we know that diabetes is a common life-threatening disease among people around the world which occurs when the glucose concentration in blood becomes extremely high. But the common methods used for the measurement of blood glucose is the invasive one, which means it involves finger pricking. As the invasive technique for glucose concentration measurement can cause a discomfort and the test strips and syringe are costlier, so with the development in the technology, non-invasive blood glucose monitoring will become more efficient, affordable and extremely competitive in the market. This portable device is designed so that it can be easily accessible and can be used anywhere. It is also helpful in consultance with the doctor without visiting the doctor. So, we have tried to make a non invasive device with as much efficiency as possible.
Hi, this is the hardware circuitry of our project powered up with a laptop. The main components of our project include the Wi-Fi based Node MCU chip microcontroller, an LCD along with it which displays the data sent by the app, and the Bluetooth sensor. The other part of the project is powered up with a simple 9-volt battery. Here is the sensing area in which user or the patient places his finger, and then this is the analog to digital converter block which converts the analog voltage received by the sensor, sends the digital form of the voltage to the controller which is displayed on the LCD. The third most important and the interesting part of our project is the app. The user interacts with the app by putting his height and weight, and then the app calculates his BMI level and sends it to the LCD as well and displays on the app as well. And finally, it displays the glucose level calculated and sent by the microcontroller. This glucose level can also be stored for the future use and for sending the data to the doctor so that the user can interact with the doctor at home.
Hi. First of all, we will power up our circuit through the temporary connection of USB cable with the laptop. The circuit and app are ready and are connected to the microcontroller via Bluetooth or Wi-Fi.
The user now inputs his height and weight in centimeters and kilograms respectively. The height and weight are displayed on LCD as well. App then calculates the BMI means body mass index and sends the data to LCD. Now the app prompts user to place finger in between the sensors in order to calculate his glucose level.
The finger is placed and now after a few seconds glucose value is calculated and displayed in the app and screen. The calculated value can also be stored in mobile along with date and time and can be viewed anytime. Thanks.
So this is the sample use of our design Android app. The app is ready and connected to the hardware via Wi-Fi. Now the user will enter his height in centimeters. Let's say we enter 172 centimeters and press the button enter. It will display the entered height in centimeters on the LCD as well, as shown earlier. Moving on to the next section, the user will enter his weight. Let's say we enter 55 kilograms, and on pressing enter, the BMI is calculated and displayed and also sent to the LCD by pressing the send button. The LCD also displays this BMI, and after some time the glucose level is calculated and received by the app from the microcontroller. This glucose level can also be stored and can be sent to the doctor via IoT on a website or his mobile on the same app, and the doctor will consult in accordance.
So this was the prototype of our project, and the final form of our device will look somewhat like this, a portable device. And the main purpose of using machine learning was to make it non-invasive and to make it as efficient as possible. The results we achieved are up to 80% efficient when compared with those obtained from the invasive methods. So say no to discomforts and pains due to finger pricking. Thank you.